Hey everyone, this video goes over the Unit 1A test review for Pre-Calc. So looking at question 1, given the functions below, evaluate g of f of -2 and f of g of +2. So we're going to start with this first one right here. So I have g, let me switch to a pen, g of f of -2. That is equivalent to us starting by finding f of 2. So f of -2 is equal to 3 times -2 squared minus 10 times -2 minus 1. You could type that directly into your calculator if you wanted to. And if you did that, f of -2 is going to equal 31. Now that we know f of -2, we can change f of -2 to 31 in our equation. So now we find g of 31, which means in our equation for g, we're going to plug in 31 for the x value. Again, 7 times 31 plus 6 can be typed into a calculator, and it would give you an answer of 223. And that would be the final answer for g of f of -2. Now, for the second one, we're going to do f of g of +2. So f of g of +2. You start from the inside, which means we're starting with g of 2. So g of 2 is equal to 7 times 2 plus 6. 7 times 2 plus 6 can be typed into the calculator. That would give you 20. So now we can replace g of 2 with 20. So f of 20 would be 3 times 20 squared minus 10 times 20 minus 1. That can be typed into the calculator, and when you type that into the calculator, you get 999. And that would be your final answer for both of those. So if you have any questions, please make sure you ask. Okay, number 2, identify the transformations from the two functions below. Well, first off, we have g of x equals log base 3 of x, and f of x equals 1/2 log base 3 of x plus 1 minus 3. So this right here is the parent function. That is the original function before any transformations. So we're going to go piece by piece and identify what's happening. Starting here, the 1/2 out in front is out in front, so it's going to be a vertical stretch or a vertical compression. Since it is between 0 and 1, it is a vertical compression. Looking on the inside, we have a +1. Remember, since it's the inside, it moves opposite, so it's really moving in the negative direction. So this is going to the left 1 unit, which would be a horizontal shift. Then I have the -3 on the outside. Since it's minus, this goes down 3 units. And this is a vertical shift. And that's all the transformations that take place. Okay? Number 3, describe the right and the left in behavior of the function below. So this one does require us to know our left from our right. So the right end is going to be this piece right here. So the right end is as x is approaching infinity. Okay, so as x approaches positive infinity, what is my y value approaching? Well, it's approaching negative infinity. So we're going to write that out. As x approaches positive infinity, my y values are approaching negative infinity. Then we look at the left side of the graph. So that's this piece over here. So as my x approaches negative infinity, my y values are approaching positive infinity. So we're going to write that for our left end behavior. As x approaches negative infinity, our y value is approaching positive infinity. So it's important to make sure that you read the question. That way you know what you're looking for. Okay? Moving on to number 4. Identify the following functions. Identify if the following functions are even or odd. So remember when we're given equations, option 1, you can plug in negative x. If everything stays the same as your original function, it's even. If all of your signs change, it's odd. Okay, and then once I go through these, I will show you what you can do to quickly identify, but it doesn't work for all functions. So here we go. If I have f of x equals a negative 1/4 x to the 6th, I'm going to evaluate f of negative x, which means anywhere there's an x, I'm going to plug in negative x and then simplify. So a negative number raised to an even exponent, the outcome is going to be positive. A negative number raised to an even exponent of 6, the outcome is going to be positive. So negative x to the 6th power is going to turn into positive x to the 6th power. When I multiply that positive x to the 6th power by that negative 4, it's going to stay negative 4x to the 6th. Well, this right here is exactly the same as what I started with. So therefore, this is an even function because my output was the same after I plugged in negative x. Now I go on to b. b says y equals 2x cubed plus 5x. Well, I'm going to evaluate it at negative x. So that gives me 2 times negative x to the 3rd power plus 5 times negative x. So I have a negative number to an odd exponent. A negative number to an odd exponent, the outcome is negative. So negative x to the 3rd power is going to be a negative x to the 3rd power. So if I take that negative x to the 3rd power and I multiply it by a positive 2, that's going to give me a negative 2x to the 3rd power. Then I have 5 times negative x. 5 times negative x is negative 5x. So if I notice here, my signs were positive, positive. Now they're negative, negative. So all of my signs changed, which means this is an odd function. So if all of your signs change to the opposite, then it's odd, but it has to be all of them. Now, looking at C, g of x equals the absolute value of x and then plus 2. So the absolute value of x plus 2, we plug in negative x. So we're going to find g of negative x. That gives me the absolute value of negative x plus 2. Well, the absolute value of negative x is just going to be the absolute value of x because it's always going to be positive, plus 2. So if I look at it, everything stayed the same. Therefore, this is an even function. Okay, you could also graph these, but I'll talk about that in just a second. I have h of x equals the cube root of x. So again, we start by evaluating the cube or h of negative x. So when I do that, I get, the cube root of negative x. Well, the cube root of negative x is actually negative cube root of x. So therefore, all of my signs changed, and this would be an odd function. So now I'm going to show you graphically so you can see the difference between even and odd functions. So if I go to my calculator and I start with a brand new graph, okay, I am going to type in that first one that we had, negative 4x to the 6th. Oops. So I have negative 4, got to keep switching it back and forth. Negative 4x to the 6th. Okay, you hit enter, it looks like this. Notice how this graph right here is symmetrical to the y-axis. When it's symmetrical to the y-axis, then it is an even function. Okay, so now I'm going to get a new graph and I'm going to type in that second answer choice. Okay, so I'm going to discard my changes. I'm going to get a new graph. And now I'm going to type in answer choice B, which is 2x to the 3rd power plus 5x. Okay, if I look at this, everything in that first quadrant lines up with everything in that third quadrant. Okay, so it is symmetrical about the origin, which is why it is odd. Then I go to C. So I'm going to start with a new graph so I don't get confused with a whole bunch of graphs. I have the absolute value of x, and then I have plus 2. I type it in. It is symmetrical on the y-axis, therefore it is an even function. And then lastly, I get my new graph, and I'm going to type in h, which was the cube root. So I'm going to use this cube root button. I'm going to type in 3 as the index number. I have x. I hit enter. If I look at it, everything in that first quadrant matches up with everything in that third quadrant, which means it's symmetrical about the origin. So this would be an odd function. So I hope visually that helped you out if you were struggling with evaluating it at negative x. Okay, so moving on, number 5, 6, and 7 are just short answered questions. So it says, odd functions are symmetrical with respect to, we just talked about that, that would be the origin. Then we have even functions are symmetric with respect to the y-axis. Lastly, inverses in their functions are symmetric about the line, and that is y equals x. Those are important things to know. Okay, looking at our next part, we have some more compositions, but this time it's using graphs. So here we go. Remember, we always start with the inside piece right here, and we need to make sure we know that this first graph is f of x, this second graph is g of x. So I start with this inside piece. This inside piece tells me that when x equals 8, what is my y value in the f function? Well, when x equals 8, the y value in the f function is right here at 0. So that tells me that f of 8 is equal to 0. So now I can rewrite it as g of 0. So now when x equals 0, what is the y value in my g function? Well, when x equals 0, the y value in my g function is right here at negative 2. So my answer here would be negative 2. Moving on to the next one, we have g of f of 2. So we start with this inside piece. This inside piece tells me when x equals 2, what is the y value of my function? So that would be f of 2. So if I go to the f graph, okay, and I find where x equals 2, the y value is right here at 3. So I get f of 2 is equal to 3, which means I can now evaluate g of 3. G of 3 means I go to the g graph and I'm looking for an x value of 3. So I go to my G graph, I find my x value of 3, and I find where it crosses the y, or where the function is, and what's that y value? That y value is 1. So G of 3 equals 1, which means G of f of 2 is equal to 1. Okay, C, I have f of g of 1. So my inside function is g of 1. So I start with that. It's telling me that when x equals 1, what is the y value in g? So I have to make sure I start on the right graph. So when g is 1, that y value is negative 3. Now I can rewrite this as f of negative 3. So this tells me that when x is negative 3, what is the y value in f? So I go to my graph, I find negative 3 on the x-axis, I find my point, it's right here. So it's halfway between 5 and 6, halfway between 5 and 6, so that would be about 5.5. So f of g of 1 is about 5.5. Looking at the next one, f of g of 0. So I start with g of 0. So g of 0 is saying that when x equals 0 on the g graph, what is my y value? So I go to my g graph, I find when g is 0, g of 0 is right here, and that was negative 2. So g of 0 equals negative 2. So I can rewrite this as f of negative 2. And now I find f of negative 2. So I go to my f graph, I find negative 2, and I look for that y value. That y value is at positive 5. So positive 5. So therefore, f of g of 0 is equal to positive 5. And that's how you do question number 8. Moving on to the next one. Identify where the function is increasing and decreasing. So when you're doing these, remember you're talking about the domain of where it's increasing, the domain of where it's decreasing. So you're only looking at x values. And you start from the left side and you work your way to the right side. So if I look here, it is increasing from there to there. So I need to find this value right here, this x value. This x value is negative 3. So it is increasing from negative infinity to negative 3. So we're going to write that. It is increasing from negative infinity to negative 3. Negative infinity to negative 3. Or we could say that the x values are less than negative 3. Okay, I would prefer the first way, but both ways are correct. Then we talk about decreasing. That's when it's going down. So this one is decreasing on this side. Okay, and again, we're wanting to talk about the domain of where it's decreasing. Well, it starts decreasing at negative 3, and it goes into positive infinity because we're talking about the x-axis. So it would be negative 3 to positive infinity for decreasing. Or my x values are greater than negative 3. So that would be increasing and decreasing. Going on to number 10. Okay, we want to identify if the following represents inverses. So remember that if it's a table, the x and the y values just switch. If it is an equation, we change f of x to y. We switch the x and the y, we solve for y, and we see if it's the same. If it's a graph, it has to be symmetric about the line y equals x. We just talked about that on question number 7. And then we learned a definition that said that inverse is if we do the composition f of g of x, and it equals x, and then we do g of f of x, and that also equals x, then they are inverses. So we're going to go and look at each individual question one at a time. So here we go. On A, we have f of x equals 2x minus 1, and this is saying that the inverse of f of x is 1/2 x plus 1. So all I'm going to do is I am just going to see if I can find the inverse of f of x and see if it matches f inverse that we're given. So step 1, we change f of x to y, and we get 2x minus 1. Then I switched my x and my y value, so I get x equals 2y minus 1. Then I solve for y. So I start by adding 1 to both sides. That gives me x plus 1 equals 2y. Then I divide both sides by 2 to get y by itself. Okay, so if I want it to look like this notation right here, I would have to understand that when I divide, I'm going to divide each individual term this time by 2 rather than one big fraction like I originally had it. So that would give me a 1/2 x plus 1/2, and that would tell me that that is my inverse right there. Well, if I look at this, what I'm given, they are not the same. Since they are not the same, that means these are not inverses. Okay, if this would have been 1/2 right there, then they would have been inverses, but it's not, so they are not inverses. You could have also done the composition to see what that looks like. But if you feel more comfortable solving like I just did, then do it this way. Looking at B, okay, we're given 2 tables. So that means that if this is my original function right here, my inverse functions table, okay, should be the points flipped. So instead of 2, 3, it should be 3, 2. Instead of 4, 1, it should be 1, 4. We're just switching the x and the y. Instead of 6, -1, it's -1, 6. And instead of 8, -3, it would be -3, 8. If I look at the table that I'm given, these don't match up. So this right here is not an inverse. Not an inverse. Or they're not inverses. Okay, because this table doesn't match the table that we should have gotten. So this table right here is why it's not an inverse. Okay, if I look at C right here, if we did not know what it should be symmetrical about, we would think that these are inverses. But this line right here is actually y equals -x. And it's not symmetrical about y equals -x. It should be y equals +x. So this right here is not an inverse because it's not symmetrical about the correct line. If I look at D, this time it is using the correct line, y equals x, but we need to check the points. So remember what we do is we label the points that we have. So let's start with the ones up top. Okay, so I go to -7, +6. This middle point would be -3, 5. And this last point would be -2, 1. Okay, then I look at the other points to see if they're the x and the y values are flipped. So this point would be 1, -2. So this and this, the x and y values are flipped. Therefore, so far we're on a good track. Okay, now I go to the next one, which is 5, -3. So if I look, that is a flip of those 2 points. So again, we're on a good track. I check my last point right here, which is +6, -7, and that is the x and y values flipped of those points. So since all of my points are just x and y values flipped, that means this is an example of an inverse. Okay, if I look at E, it says the composition of f of g of x is equal to the composition of g of f of x, and that equals x. That is the definition of inverses. So this is an example of something that would be an inverse, because it's the definition. Okay, lastly, I look at f. So this is an equation. So we're going to start by changing this to y. I am going to switch my x and my y values. And then I start, by solving for y. So step 1, I add 6 to both sides. That gives me x plus 6 equals 1 over y minus 3. I need to get that y minus 3 out of the denominator. So to do so, I'm going to multiply both sides by y minus 3. But when we do that, I need to make sure that goes in parentheses, and I do y minus 3 like this. So what happens is this cancels out that, and it leaves me with y minus 3 times x plus 6 equals 1. Now I need to get that x plus 6 on the other side. So I'm going to divide by x plus 6, divide by x plus 6. When I do that, these cancel out, and it leaves me with y minus 3 equals 1 over x minus 6. Lastly, I need to get y by itself still, so I'm going to add 3 to both sides. When I do that, I get y equals 1 over x minus 6 plus 3. That is the same thing as this right here, which shows me that they are inverses. Okay, going on to number 11. Number 11 just wants us to identify some key features. So looking at it, we're going to start by identifying the zeros. The zeros are the same thing as x-intercepts. So this crosses the x-axis at 3 different spots. So the first one right here is at -2, 0. The second one in the middle is right there at 1, 0. And the last one right here is at 4, 0. Okay, the y-intercepts, where it crosses the y-axis, so that is this part right here, and that is at 0, -4. The domain for this, remember our domain is our x values, our range is our y values. So this is going to keep expanding to the left, keep expanding to the right. So my domain is -infinity to +infinity, or we say all real numbers. My range is my y values, so it goes bottom to top. It's going to keep going to the bottom forever, keep going to the top forever. So my range is the exact same thing, -infinity to +infinity, or you can say all real numbers. Okay. Next, it says label the relative min and or max, so whatever it has. So this point right here would be the relative max. This point right here would be the relative min. Lastly, it says label where the graph is increasing, decreasing, or constant. So if I look right here, we're going to start with increasing. So from the left to the right, it would be from here to here. That part right there is where the graph is increasing. Okay, if I want to talk about where the graph is decreasing, that would be from this part right here. That's the first part, and then this part right here would be the second part. So that would be decreasing. So it would be decreasing from negative infinity to that x value of the relative min. Then it would be increasing from that x value of the relative min to the x value of the relative max. And then that x value of the relative max to positive infinity, it would be decreasing again. So remember, when we do increasing or decreasing, it's talking about the domain of those sections. So you're just using the x values. Looking at the next one, identify the domain and range of each graph. Okay, so if I'm looking at this graph right here, and I want to do domain again is my x values. So I look, and it is from -9 to 2. So I have two ways I can write this. How I would write it first would be, I have an open circle, so that's parentheses, -9 to 2. And since it's a closed circle, it gets a bracket. Or a way you may see it is -9. Since it's an open circle, there's no line. Then I have an x in the middle. And then since I have a closed circle, it gets a line with a 2 on the outside. Those are the exact same thing, just written in a different way. My range is my y values, and so we go from the bottom to the top. So from the bottom, it's starting at -6. From the top, it's ending at 3. So I would have -6 because it has a closed circle, to 3 with the parentheses because it has an open circle. Or we would say -6 with a line underneath, a y in the middle, and 3 with no line underneath. Those are the same things. Okay? Looking at my second graph right here, again, my domain is my x values. So if I look from left to right, it starts at 0 and it ends at 230. So my domain would be from 0 to 230, both of these included, so they both get parentheses. Or we would say 0 with lines underneath to 230 like this. My range is my y values. Okay, I start from the bottom and I work my way to the top. The bottommost y value is 0. The topmost y value is 36. Okay, this 6 right here is included in the middle, but it is not our lowest one, so we do not use that as a value. Okay, so it would be from 0 to 36, or 0 with a y in the middle to 36. Either one is correct. So if you're not in honors, you're done with the review. You can go ahead and end the video. If you're in honors, you need to continue for the next 2 questions. Okay, so my next 2 questions. What is the sum of the zeros? So we need to find the zeros, and then we need to find their sum. All that means is we're going to add them. So remember, sum just means add. So my first 0 is at -2. My second 0 is at 1, so I'm going to add that. My third 0 is at 4, so I'm going to add that. So -2 plus 1 plus 4, that would give me 3. So my answer for the sum of the zeros is 3. Looking at the next one, for which of the following is f of g of f of g of 2 equal to g of f of 2? Basically, what this is asking is which are inverses, okay? So however you want to go about this is what is going to be best for you. You can do the compositions and see which ones get you the same values when you do both competitions, but this is basically the definition of inverses. So if I were to change that 2 to an x, and I change this 2 to an x, it's basically saying which ones are inverses because I'm going to get x as an output. So if you just want to find the inverse of each function and see which ones are inverses, do that. If you want to do the compositions, then do that. In the work notes, I have the work for doing the compositions. In the video, I'll show you how to do it, just finding the inverses and seeing if they match. Okay, so I'm going to copy these to another page so I can work them out. So if I'm starting with A, okay, I'm going to start with f of x equals x minus 4 over 3. Okay, I'm going to change f of x to y. I am going to switch my x and my y values, so I get x equals y minus 4 divided by 3. If I want to solve this right here, I will multiply both sides by 3. That gives me 3x equals, over here, those 3's cancel out. So I have y minus 4. I add 4 to both sides, add 4 to both sides. That gives me 3x plus 4 equals y. So if I rewrite this using inverse notation, it's telling me that my inverse should be 3x plus 4. If I look at my answer choice, that is what it says my inverse is. So therefore, A would be something that works out. Okay, moving on to B. So we have f of x, and this is for B, f of x equals x squared minus 1. I change my y, or my f of x to a y. And then I change my x and my y. I solve for y now. So I add 1 to both sides. That gives me x plus 1 equals y squared. Remember, I take the square root of both sides, but when we take the square root, you have to remember the plus or minus. So I get plus or minus the square root of x plus 1, and that equals y. Well, if I look at it, that is not the same thing that it has right here. So B is not an answer. Moving on to C. So C, I'm going to work down here, which says f of x equals x cubed plus 3. So again, we start, we don't need that line right there yet. We start by changing f of x to y. I get x cubed plus 3. I switch my x and my y. Now I solve for y again. So I start by subtracting 3 from both sides. That gives me x minus 3 equals y cubed. Then to undo something that is cubed, I take the cube root, which is a little 3 on the index. And that gives me the cube root of x minus 3, and that equals y. If I look at my answer choices, that is what it has right there. So therefore, C would be an answer. Now I do D. So D says f of x is equal to 3 over x minus 6. So I start by switching or changing my f of x to a y. Then I switch my x and my y. And then I solve for y. So I add 6 to both sides. That gives me x plus 6 equals 3 over y. So I can multiply both sides by y to get y out of the denominator. So that gives me y times x plus 6 equals 3. Those cancel out. I want to get y by itself, so I'm going to divide by x plus 6. Divide by x plus 6. So I get y equals 3 over x plus 6. If I look, that's not what this has, so that is not an answer. And so I would have 2 answers for this one. If you have any questions, make sure you ask so you can get help before the test. Good luck on your test, and I will see you in the next video.